sharing as it should be?
Yes, that's fine, Nick. We can see that, yes.
Excellent. Okay, thanks very much. So yeah, as mentioned, I'm Nick Rothwell. I'm the Principal Sustainability and Carbon Consultant at Atkins. And today I will be presenting around whole life carbon management in the rail industry, based on the article that I wrote for PWI last year. So this session will go into details around the sort of principles of whole life carbon management, and then specifically around carbon accounting, so calculating carbon using the RSSB rail carbon tool. So sort of approaches for carbon calculation, and then we'll go through some case studies at the end as where we've done that on rail projects in Atkins, and then obviously we'll have Q&A at the end. So a little tiny bit about us at Atkins. So our approach to carbon management is at the core of our engineering net zero initiative, with a vision of embedding sustainability in everything we do, progressing attitudes within the industry, and aspiring to make all schemes in which we're involved net zero by 2030, which is going to be very difficult, but is a challenge we're taking on and doing everything we can to achieve. So I'm part of the Atkins Whole Life Carbon Management team. We specialise in carbon management of large infrastructure projects, and work with the whole supply chain to enable whole life low carbon solutions. And we are carbon quantification reporting specialists, and we're the original developers of the rail carbon tool. So a quick session overview. So the session explores whole life carbon management for the rail industry in the context of the wider net zero agenda, and then going, as I mentioned, specific details around use of the rail carbon tool. But the overall aims of the session, I would like to try to, if possible, demystify carbon management and quantification to help people embed sustainability best practice. So to kind of think sometimes there's possibly a misconception that carbon management is really difficult, really complicated, and is really challenging. I want to try and show that's not always the case. It's a lot of what we are talking about is quite simple, and some of the things that we're doing anyway. It's just kind of looking at it through a lens of from a kind of carbon lens. Looking to provide guidance and effective use of carbon calculators such as the rail carbon tool, and then also demonstrate case study examples of managing carbon in infrastructure, and quantifying the benefits using the rail carbon tool. So a bit of a background, taking a step back. So I hope everybody's aware that climate change is one of the critical global issues within today's society. Meeting net zero emissions targets is therefore paramount to avoiding further impacts of climate change. And the transport sector represents around 27% of the UK's greenhouse gas emissions. So that's the challenge that we're working within as people working in the transport sector, and specifically within rail. Traditionally, the focus of carbon reduction efforts has been on operational emissions from fuel combustion. So typically, say, the trains on the tracks. But as vehicles decarbonise through electrification and decarbonisation of the electricity grid, whole life carbon of transport infrastructure is becoming increasingly important. So that's all of the infrastructure, all of the materials that we use, the construction processes in building and operating the railways, so everything that goes with those trains moving around. And so that's the kind of main focus of the session today, and what I'll be talking about. So a bit of a background on UK net zero targets. So the Paris Agreement of 2015 aims to keep global temperature rise this century below 2 degrees C, above pre-industrial levels, and encourage efforts to limit temperature increase even further to 1.5 degrees C if possible. And I think last time I checked, we were on track for sort of 2.7 degrees of warming, so we still got a long way to go to meet those targets. In response, the UK statutory target for reducing greenhouse gas emissions was strengthened in 2019. So we have a net zero target of net zero by 2050. The Committee on Climate Change defines net zero emissions as the point when the total of active removals of carbon from the atmosphere offsets any remaining emissions from the rest of the economy, which is a bit of a mouthful, but basically means we need to reduce carbon as much as we can. And then any residual emissions that are left over need to be reduced or removed through active sequestration, so tree planting and things like that. Understanding how to identify carbon emission sources and then how to effectively manage those sources to create carbon reductions is paramount to achieving net zero, and it's that we'll be focused on today. So a bit of a background now around greenhouse gas emissions in the rail industry specifically. So rail is already one of the lowest carbon forms of transport, accounting for just 1.4% of the UK's domestic transport emissions, despite 9% of transport being carried out in the UK's railways. I think that's 2019 data, so it may have changed a bit, but roughly that's the sort of order of magnitude we're considering. Over 40% of the UK's railways are already electrified, enabling the transport of passengers and goods with minimal greenhouse gas emissions being released in those operational emissions. As electrification of the rail network extends and the national grid continues to decarbonise, this mode of transport is becoming even less carbon intensive. However, emissions associated with the construction and maintenance of rail infrastructure will become the main source of emissions once those trains are fully electrified. And it's that which, as sort of designers and contractors and constructors in the rail industry, that we have control over those emissions. And it's sort of our responsibility to make those as low as possible. So consideration of the carbon emissions across the whole life of projects is therefore paramount to reaching net zero. And the Department for Transport's plan, Decarbonising Transport, A Greener Better Britain, states that a joined up approach across the supply chain to managing whole life emissions will be critical to achieving net zero. So a lot of what I'm talking about it touches on supply chain engagement and collaboration across the supply chain to work to decarbonise our projects. So first, before I go too far, I just wanted to give a kind of update and a catch up on exactly what whole life carbon emissions are. So in case anybody's not completely familiar. So you may have heard terms like embodied carbon, construction carbon, capital carbon, operational carbon. There's all sorts of different elements of carbon out there, but I'm talking about whole life carbon, which is all of the above effectively. So that's everything from the extraction of raw materials, so literally taking those materials out of the ground, transporting of those raw materials to a factory, and the manufacturing of products. So that might be manufacturing concrete or steel into sort of standard products. Those three stages together form our sort of embodied carbon. Then we have the transportation of those products to our construction sites and the various different transport legs, different transport modes to get materials from A to B, and the emissions associated with that transportation. Then the construction of assets, so the plant usage, so fuel and energy use on site. Then the use and maintenance of the asset, so that's our operational emissions. So that may be energy and fuel and water use during the actual operation of an asset. But it also includes the maintenance, repair, replacement and refurbishment of an asset during its life. So that might include new materials, transportation of those materials, construction processes to maintain that asset. And then finally, when it reaches its end of life, there's the demolition of the asset and the emissions associated with that demolition, haulage away of waste material, waste processing, and finally waste management, things like landfilling, recycling, incineration, and all of those processes. A combination of all of those emission sources are what we call whole life carbon emissions. And we're trying to consider all of those emissions right from the earliest stages of our projects so that we're not sort of short-sighted and just looking at one element of it. We're making sure that the decisions we make are the lowest across the whole life of our projects. But I'll come on to this over and over, I think, through this session. But if people have further questions on that, feel free to ask at the end. So whole life carbon emissions, as I just explained, can be described in sort of modules, those life cycle stages. We tend to use the life cycle modules as set out in PAS 2080, but those are sort of informed by other technical standards. But these life cycle stages cover the whole asset life. So what I described earlier, the embodied carbon, so the materials, raw material supply, transport and manufacture, that's your A1 to A3 emissions, transport to the work sites A4, construction process emissions is A5, And then collectively, they form your sort of before use stage, or construction carbon is sometimes referred to, or cradle to gate emissions. Well, actually, A1 to A3 is cradle to gate, A1 to A5 is cradle to construction. Then you have your in-use stage emissions, which is what I mentioned before, which is the B stages. And then finally, end of life, which is C1 to C4. So I mentioned PAS 2080 there. It's our key technical standard for management of whole life carbon in infrastructure. It aims to improve the management of carbon throughout the supply chain, and enables evidence-based decision making and the identification of carbon reduction opportunities, and provides a common framework for the whole supply chain, encouraging the right behaviours and approaches to deliver reduced carbon and cost. So PAS 2080, whilst it covers the methodologies for carbon calculation, it mainly covers the management processes for the whole value chain. So all of the roles and responsibilities across different supply chain stakeholders in what they need to do to manage carbon, from the client, the designer, the contractor, and then onward supply chain. And so it's a really valuable standard, and we try to follow the principles of carbon management in the work that we do as much as possible. It should be noted that PAS 2080 is being updated this year, and I think we're expecting the update to be released in April. I've seen early versions, and it kind of follows the same principles as the original, but just enhanced with more thinking, since it originally came out in 2016. So interested to see it in detail when it comes out. But the key requirements or key themes of PAS 2080 are set out on the left there. So we have leadership and governance, the carbon management process, quantification of greenhouse gas emissions, target setting, baselines and monitoring, supply chain engagement, and continual improvement. So leadership and governance is all about setting an organizational strategy for carbon management, and critically assigning roles and responsibilities so people understand the part they play in reducing carbon, and encouraging the challenging of the status quo. So the critical part of that is assigning roles and responsibilities. So one thing that I've learned in the work that we've done is that everybody within the supply chain has a role to play in management of carbon emissions. And so assigning roles and responsibilities so people understand what's expected of them, what they're responsible for, what they just need to understand and know about, is critical to making this work. And that all comes from leadership and governance, mainly from the client organisation sort of driving the project. Then the carbon management process, so integrating carbon management activities into standard project delivery processes, ensuring carbon information feeds into decision making from the earliest project stages. So this is all about taking the standard approach to project delivery. So not trying to change the way we deliver projects, but trying to integrate carbon into our standard project delivery processes, and making it a part of our business as usual approach to design and build of a infrastructure project. Then we have quantification of greenhouse gas emissions, so using relevant tools and processes to quantify and report carbon through project delivery and feeding into decision making. So that's like using the rail carbon tool, and is all about creating the right data and the right level of information at each stage throughout the delivery of the project. So it can be quite high level at the beginning, but gets more refined and more detailed as time goes on. Target setting, so setting challenging carbon reduction targets against the defined baseline, and establish key performance indicators to monitor emissions during project delivery. So that's fairly straightforward, but having a target that everybody can work towards, having a set baseline that we can compare back against and understand our progress, is really key. Supply chain engagement, so engaging the supply chain early, collaborating with the whole supply chain from the earliest project stages to share carbon objectives, identify innovative low carbon solutions, and removing any constraints to collaboration. This is really critical. So it may be that, the very earliest stages, reaching out to potential suppliers of products and to understand what products are available that could reduce carbon in the delivery of the project, and then understand what needs to be in place to enable the use of those. So it might be sort of changing standards and things to be able to use new and innovative products, the earlier we know about that, the more likely we are to be able to use them and to kind of put those into practice. And then finally, continual improvement. So seeking the input of the whole supply chain to improving the carbon management process. So that's just about being open to suggestions and continually driving improvement in the process, project delivery processes. Sip of water. So integrating carbon management into the project delivery. So this is set out in PAS 2080 as well, and is our carbon reduction hierarchy, which I'm sure some people on the call have heard about, which is build nothing, build less, build clever, build efficiently, operate efficiently. So what this is about is at the very earliest project stages, we have the greatest opportunity to reduce carbon. So at the earliest project stages, say concept and planning, we actually have the ability to reduce 100% of emissions because we could choose to build nothing. And this is really effective when we're looking at projects or looking at whole programs of projects where we can make those sort of strategic level decisions to say, is there an alternative way to our whole strategy for the program? Could we remove the need for certain assets or certain projects, thereby reducing 100% of the emissions? More than likely, you will have to build something. And so when we get into the planning and design stages, we're talking about building less. So working out what it is what problem we need to solve and trying to build as little as possible to solve that problem. By reducing materials quantities, reducing the size of what we're constructing, that sort of thing. And there we have the opportunity to maybe influence, say, 80% of emissions. As time goes on throughout the project, we move into the, say, construction planning and construction delivery stage. We only have about 40% of the emissions that we're able to influence. And this is where we're considering things like building clever, which is around identifying low carbon materials, low carbon that we can use instead of standard materials, low carbon construction practices, so electric equipment on site, hybrid equipment, plant telematics, that sort of thing. And then as we move into operation, we have operate efficiently. So that's around just using the infrastructure in a sustainable way. And at that point, we can only influence, say, 20%.
Nick, sorry, Nick, I don't want to interrupt. Sorry for interrupting you, but there seems to be a small problem with your slides because the slides are taking a long time to catch up.
Okay. I'm hoping, can you see the right slide now?
We're looking at the PAS 2080 slide, key requirements. So I think you're probably on the next slide.
I will stop sharing and start sharing again.
Okay. This seems to be stuck a little bit. Sorry to interrupt.
No, I'd much rather you tell me than everybody be looking at the wrong thing. So that's thanks
well,
for that.
It's easy to follow you as well, what you're saying, but I know you'd want people to be looking at the correct slide too.
So hopefully you can now see the carbon reduction hierarchy slide on screen.
Right. We're just waiting for it to pop up.
Okay, right. Still, let me know when you can see that.
Not yet. No, still got a blank screen. Well, people are putting a thumbs up as if they can see it. Oh, they can see it. It's me now. I can't see it now, so it's me.
Okay, maybe could somebody else?
We can see slide 11 at the moment.
Yeah, so, that's good.
Yeah.
As maybe Jade, that has the slides been following correctly for you throughout the rest of the session so far?
Yeah, so far.
Okay.
Yeah, and other people are saying that as well. So it's obviously me.
Okay. All right. Well,
okay.
If anybody else is having that problem, just shout up and we can pause as we go and try to reconfigure it. But hopefully most people are seeing the right slides.
Sounds like it's mostly me. So sorry.
No problem. Okay, so carbon reduction hierarchy. One of the key messages, I guess, to get across on this is the earliest we the earlier stage we can start considering carbon, the higher potential we have to reduce carbon effectively. So if we can be influencing decisions at that strategic level, or at the very earliest planning and design stages, we still have the opportunity to influence and reduce the majority of the emissions. If we don't start thinking about carbon until construction or later, our opportunity to reduce them is greatly minimized. So whole life carbon assessment. So this is around actually calculating carbon. So I want to start with the fundamentals, and this is around that sort of demystifying that I mentioned earlier. I think sometimes I've spoken to people who seem to think it's extremely complicated, but ultimately at its most basic level, greenhouse gas emissions calculation is activity data multiplied by an emissions factor. So your activity data is your project data. So say quantities of material or litres of fuel being burnt in a vehicle, and your emissions factor is a coefficient, as you can see in bullet 3, representing the average emissions associated with a single unit of a specific source. So, for example, the average emissions associated with the production of a ton of concrete. So carbon emissions tend to be expressed in carbon dioxide equivalent, or CO2e, which represents the global warming potential of all greenhouse gases released by an activity put in the context of carbon. So basically CO2e is putting all the greenhouse gas emissions in the context of carbon. So it is accounting for everything, but we just, to put it simply, we call it carbon. Carbon factors are provided by various carbon factor libraries and cover all processes across the project lifecycle, including products and materials. So your embodied carbon, we have carbon factors for those. Vehicle transport, so traveling a kilometre by a certain vehicle, we can understand the emissions associated with that. Construction processes, so burning diesel in a certain type of engine, we understand emissions from that. So fuel use, energy use, water use, as well as then end of life processes. So we kind of combine our activity data of understanding what we're doing on the project with the emissions factors and build up carbon calculations. And it really is as simple as that. Carbon modelling. There are several components that must be understood before carrying out any carbon modelling. So the life cycle of the project or asset and where the measurable emission sources exist. Data sources, so including project-specific input data as well as appropriate carbon emissions factors. So where are we going to get our data from for each of the life cycle stages, and where do we have the emissions factors to be able to build up those calculations? A robust assessment methodology that's aligned with relevant technical standards. So Section 7 of PAS 2080 is all around actually calculating carbon. So sort of following those standards in the way that we calculate carbon is pretty key. Defining our system boundary. So outlining the physical and geographical boundaries to be included in the assessment, as well as inclusions and exclusions within that boundary. So basically understanding how big or small our assessment is. And this becomes really important where you say have a really big project and you're doing a carbon calculation of individual aspects of that project. So how much of that project is included within that assessment? So where do you draw the line? And then also the reference study period, which defines the time period for the assessment and consequently the range of operational activities for which emissions will be accounted for. So, for example, energy use during the operational lifetime of that asset, and then the maintenance and replacement. That becomes really important when we're comparing options. So you might have the required lifetime for a project might be, say, 100 years, and you have different options that you're considering, and you're calculating carbon of those different options. But some of those options might last the full 100 years, and others might only last 50 or 25 years. And in which case, we need to be able to make a fair comparison. We would have to calculate a full lifetime and a full replacement of that option to be able to assess across the full time period. But I'll come on to that a bit later on. So levels of assessment. There's whole life emissions should always be considered, but don't always need to be calculated or quantified. So what I mean by that is at the earlier stages, qualitative discussions may be all that's required. So what I've tried to do is map the types of assessments we might carry out across the GRIP stages for rail. So in the very earliest stages in your output definition, all we may do is sort of qualitative assessment and discussion of potential emissions with no real calculation taking place. In GRIP 1 to GRIP 3, where we're doing our earliest feasibility and option selection, we might do what I call anyway targeted whole life assessment. So that's rather than calculating carbon for everything across the whole project, you just calculate carbon for the options or the things that you're comparing. And you consider whole life emissions, but you only include the elements of the life cycle that are impacted by the decision making. So an example of that might be you're, say, looking at, let's take a bridge for an example. You're comparing a concrete or a steel bridge option. If both of those options are, they take the same amount of time and the same processes to construct, they last the same amount of time and require the same maintenance. I'm not sure that's true, but if that was true, you wouldn't have to include all of those emissions. You'd only include the materials associated with so the concrete and the steel bridge and compare those, because that's the only thing that's going to change in the assessment. However, if one did take a lot less time to construct or last a lot longer or require less maintenance, we need to include those life cycle stages to make a fair comparison between our options. So that's what we mean by sort of targeted whole life assessment. And then later, as we go into sort of single options development, detailed design and construction, that's where we really should be doing whole project, whole life assessment. And the reason for that is once we've got a single solution, we want to calculate carbon across the whole project so that we can identify what we call carbon hotspots to understand where the majority of the carbon sits within that whole project so that we can go after the biggest carbon hotspots, which are likely to be our biggest opportunities for carbon reduction. So in later stages, whole project emissions performance should be tracked and compared back to the project baseline. So at early stages, we need to establish a baseline. And also, I'll come on to this in a bit more detail later on, but one of the sort of intrinsic issues we have with carbon calculation is at the earliest stages, you have the biggest opportunity to reduce carbon, and your decisions that you make are the most critical in terms of reducing carbon. But those are also the stages you have the least amount of data. So that's where these sort of targeted assessments are about. You may need to make assumptions. You may need to bring in previous previous project information to support those calculations. But it's kind of key to do that because they're your biggest opportunities. So data collection for your whole life cycle. So you've seen this diagram before, but I've tried to map out the types of data that you might need for each of those stages. So if you're embodied emissions or A1 to A3, so your raw materials to product manufacture, that's your material quantities or bill of quantities. The transport is your transport mode and source location. Construction is your plant, fuel and energy use, and so on. I've kind of gone through that already. So as I mentioned in the previous slide, assumptions and estimates may be required at the earliest project stages. And this really requires early engagement with all disciplines and stakeholders. So it's kind of particularly where we need to make assumptions and estimates, it's really key to be working with the correct stakeholders to understand where we may have calculated this before, and we can bring in those calculations or be able to kind of estimate the types of materials that may be required for certain options before we've actually designed them to be able to feed into those decisions. A lot of the data we're talking about here, particularly as we get into later GRIP stages, is already captured as part of normal project delivery processes. So it's normal. We would have a bill of quantities, maybe sort of lower level of detail at early stages, but it gets more refined, and that is a key source of activity data to feed into our emissions calculations. Transport mode, source locations, plant fuel and energy use is typical information you would have in a construction management plan. So that's another key source of information. It's typical to understand your asset life, maintenance requirements, energy use during construction. It tends to be the end of life stages, so demolition and waste transport and waste processing, which not almost always requires assumptions and estimates because it's not something we typically plan for. So again, it's important that all stakeholders know their role early on, for example, in providing data. So the kind of logistics of doing this in a project, often as a carbon person, if I'm carrying out a carbon calculation, I'll be reaching out to engineers to provide carbon data. And if they don't know that I'm going to be reaching out, it can be a bit of a shock and it might not be planned in. They might not have the time to be able to do it. So making sure they know that that request is coming early, when it's going to come, what I'm going to be asking for. That's really important for this to go smoothly. And so we get the right information at the right time that feeds into the correct decisions in project delivery. Just going to have a sip of water again. So the benefits of whole life carbon assessment. So carbon calculation is most effective when feeding into into optioneering stages and project decision making. So again, that goes back to the earliest stages of the project are most effective for key decisions, and having as much data and as much carbon information as possible to feed into those decisions will lead to the biggest reductions. Carbon calculation enables project teams to identify carbon hotspots where the opportunities for carbon reduction are greatest. It enables project teams to make more informed, sustainable choices. And whole life consideration ensures that all emissions are considered across the project lifetime, not just upfront carbon. So that's why whole life is really important, rather than just say an embodied carbon calculation, or at least consideration of whole life implications of our decisions. Because you may have examples where the upfront carbon is lower for one option, but actually it has a higher impact overall. So an example of that, which I haven't included in my case studies, is we had a project for an airport, actually, so a different sector. We were looking at wastewater pipework infrastructure, and we were comparing 3 different options. We had one which was plastic HDPE pipework, one was stainless steel, and one was cast iron. So the existing pipework was HDPE, and that needed to be replaced because it was at its end of life. We carried out a carbon calculation, but the embodied carbon, or upfront carbon, the plastic pipework was much lower carbon than stainless steel and cast iron, mainly because it weighed so much less. You need overall sort of lower weight of material. However, when you carried out a whole life carbon calculation, the HDPE pipework only lasted, I can't remember exactly, to say 10 years, whereas the stainless steel and cast iron pipework lasted sort of 50 years plus. So that was a key consideration, that you would have to replace the plastic pipework more frequently to match the lifetime of the other options. And then also it required more maintenance. And then at the end of life, the plastic pipework wasn't suitable for recycling, so would have been likely have to be incinerated, whereas the stainless steel and cast iron pipes were almost perpetually recyclable. So when we carried out the whole life emissions calculation, the stainless steel option came out much lower than plastic, despite the plastic being upfront much lower. So those sorts of scenarios happen quite frequently. So whole life consideration is really important. So whole life carbon reduction regularly aligns with whole life cost reduction. So driving carbon reductions and driving that whole life consideration can often lead to whole life cost reduction as well. And sort of bringing those two concepts together can be really effective. So now going into specifically the rail carbon tool, and actually kind of taking some of those processes I've talked about and using a tool to deliver this, we have freely available web-based carbon tool for the rail industry. It includes premium carbon factors, carbon factor libraries like the inventory of carbon and energy, or the ICE database, and it's fully capable of whole life carbon calculation. So every stage that I've talked about, from the embodied carbon right through to the end of life, all of those processes and sub-processes can be included if the right sort of methodology is followed. and we adhere to the principles of PAS 2080. The tools hosted by our SSB was originally developed by Atkins. So now finally, I'm just going to move on to some case studies. So case study 1 is, so I've focused on rail case studies, obviously, but I have sort of other examples I could talk through, maybe the Q&A if people are interested, but Soham Station redevelopment. So Soham Station, Cambridgeshire, was closed in 1960s following an accident on the tracks. Following a long campaign to rebuild it, the station was reopened in December 2021. During the design and optioneering, Atkins used principles of PAS 2080 to make low carbon decisions and then quantified carbon in the rail carbon tool, feeding into wider options appraisal. So Network Rail needed to decide what type of platform should be built at the station. There were 5 different options, which I'll go through, as well as understanding the carbon benefits of design decisions that were made. So a targeted assessment of the 5 platform options was required, considering cost, constructability, and carbon. And a full project assessment was required to quantify carbon benefit of design changes throughout the options appraisal stage. So that, as I mentioned before, we did sort of targeted assessment looking at just the options for the platforms and only included the life cycle stages that were key to that decision. But then we, as the project went on, we carried out a full project carbon whole life calculation to track performance and understand the implications that the decisions were made and compare back against the project baseline. So Atkins used the rail carbon tool to carry out a targeted assessment, which included a comparison between red brick, crosswall and plank platform, steel modular platform, GRP modular platform, polystyrene platform, and a concrete platform. And then low carbon solutions were sought within all aspects of the overall design by integrating the principles of the carbon reduction hierarchy, by carrying out carbon reduction workshops, which brought together stakeholders from across the project delivery and the supply chain to identify carbon reduction opportunities that could be sort of taken forward and explored in later design stages or project delivery stages. A full carbon model was developed covering the whole station, which included the footbridge, as you can see in the picture, access road, car park, shelters, signalling structures, and the platform. The full model was used to identify carbon hotspots and subsequent reduction opportunities, as well as then demonstrating how carbon had been reduced across the appraisal stage. So then the results of the assessment, so of the targeted assessment of platforms, you can see in the graph here, the polystyrene modular platform overall had the lowest carbon. GRP was substantially higher than the other options. And then that assessment delivered a carbon reduction of 49% against the baseline option, which was the crosswall and plank. That was our baseline. And the suggested solution was polystyrene modular. And based on the results of the assessment and the wider aspects of the options appraisal, that was the option that was chosen. So that reduction was achieved. And then through embedding the principles of carbon reduction hierarchy and through those carbon workshops and wider design and project delivery processes, further carbon reductions were achieved, resulting in a reduction of 18% across the whole station design. Case study 2 is Mary Hill electrification. So this has involved electrification of Mary Hill railway line that runs between central Glasgow and Anniesland. The existing road bridges that were crossing the tracks at 3 locations didn't have enough clearance to fit the required overhead line electrification equipment. So either the bridges needed to be raised to accommodate that additional clearance that was required, or the tracks underneath the bridge needed to be lowered to accommodate it. But lowering the tracks also meant lowering platforms nearby of nearby stations. So a comparison was required of the costs and benefits of raising the bridges or lowering the tracks at the 3 different locations. And greenhouse gas emissions assessment was required to consider the environmental impact of the 2 options across those different locations. So we used the rail carbon tool to carry out a whole life carbon assessment of the 2 route clearance options. So this involved gathering whole life carbon data, which, as I mentioned before, includes the materials, bill of quantities, transport distance of materials, construction processes, fuel and energy use, operational processes, maintenance requirements, and end of life treatment of materials. So the results of that assessment, so overall the raised bridge option across the three locations was considerably lower, as we can see, compared to the track lower option. The main reason for that was the fact that you wasn't just lowering the track beneath the bridge, that to be able to lower that, there meant a long gradient of track had to be lowered as well to lead into that clearance. And then the platforms nearby also were disrupted and had to be changed. However, that was in contrast to the overall preferred option of lowering the tracks, which was the result of increased disruption on raising the bridges. So the traffic disruption that would have happened from raising the bridges was so severe that that wasn't the preferred option. So whilst the preferred option was to lower the tracks, despite higher carbon intensity, the whole life assessment still enabled the identification of various carbon hotspots within the track lower option that was taken forward. And that led us to targeting reductions in quantities of high impact materials like reinforced concrete within the con arch and parapet components. So we were driving carbon reductions in the solution that was taken forward. So we were looking to maximise the reuse of Site 1 materials elsewhere on site, and then use rail for material transport, as well as electric and hybrid plant on site. And that's it. Those are the case studies. Thanks very much for listening. I think we're at 45 minutes, which is reasonably good timing. So yeah, just open up for questions.
Yeah, that was an excellent presentation. Thank you very much indeed, Nick. So I'm sure we're going to get lots of questions here because we've got a lot of people on this call, which is great to see. So rather than putting them in the chat, would anyone like to put their hand up and ask the question? I think there might be one question in the chat. So Jamie, do you want to ask your question first?
Yeah, sure thing.
Go for it.
It was just a question around where you get the information of the quantities of the materials you're putting into your carbon calculations. Is this kind of more of a manual process, or are you using BIM to get this?
So it varies. Really good question. It varies on project stage and the tools you're using, to be honest. So if you have at the earliest project stages, as I mentioned, before you've really got into the detailed design in any way, it's unlikely that you're going to have maybe even you might not even have a detailed bill of quantities. You're very unlikely to have a sort of BIM model or anything like that to get your quantities from. And so that's where you there's lots of collaboration, say, between the carbon team who are carrying out the calculations and the engineering teams to understand where you might have calculated carbon previously and can bring in those calculations to say, okay, it's similar to this, but we tweak it a little bit, or make assumptions on the quantities or sort of materials used or construction processes. Then as stages go on, you might have a bill of quantities that you can reach into for data. And then ideally later, you might have a BIM model that you can extract quantities data from. And some tools that are being developed, things like one-click LCA, they can be linked directly into BIM. And so you can have automated materials quantities coming out of BIM and into your carbon calculations and things. Although it's kind of new, and often they still need some manual input from the material side, because you get issues with BIM where, say, for instance, things in BIM are described as 3D objects, but things like the reinforcement doesn't automatically get captured within the data set and feed into your carbon calculations, which would make quite an impact. So at the moment anyway, there's still quite a lot of manual information capture and feeding into your assessments that's required. Yeah, hopefully that answers your question.
Yeah.
Just before I bring Rohit in with the next question, can I just ask her then, because of all of that manual intervention, etc., does that then drive sort of behaviours and people sort of say, oh, this is all too difficult, let's not do this?
It can do, and that's where understanding the approach for carbon management on the project early on, and sort of understanding that it's a key part of the project delivery process is really important. We're getting clients now who are asking for this at from the outset of projects, and projects are being won or lost on how carbon is going to be managed on the project. So it's when I first started on this sort of 5 or 6 years ago, carbon was like sort of add-on. Quite often it was, say, there's a pot of money left over, let's do a carbon assessment and see, and let's look back at the decisions that we've made and understand how much carbon we've reduced. The industry's changed now, and much more it's being asked for from the outset. How are you going to manage carbon on this project? How's carbon calculation going to be integrated into the project delivery? So, and I think that will just continue. So
That's good.
But also just to say as well, when I brought up that the grip stages and the different type levels of assessment, what we try to do as much as possible is not overdo it at the early stages and say we need to do whole life calculation across the whole project. If you can do targeted assessments like I was describing, where you pull together the data required to feed just that decision, that will help make those early decisions and probably make your biggest carbon reductions. And those can be pulled together pretty quickly, particularly if you have a sort of carbon person who knows how to use the tools and knows the methodologies. So it doesn't have to be a sort of really detailed process. It's normally later in those stages, but that it's a bit more complicated, but then you have all the data, so it's a bit easier and less time consuming.
Okay, thank you. So go on ahead, Rohit. You've got your hand up for a while. Sorry to take over
That's
from
absolutely fine. That's absolutely fine. So my question is related to case study 2, Nick, where you talked about track lowers and replacement of bridges by raising them up. We did talk a lot about what the carbon assessment tool would bring in. That being that bridges would be a lot more carbon effective than the track lowers, isn't it? So the question I have over here is, has a cost comparison also been taken into consideration? Because typically what we see is bridge replacements are a lot more expensive than track lowers.
I think
so. When it comes to a cumulative decision, has that been taken into consideration? And if so, what does the client or the boards usually tend towards? Would it be carbon or would it be cost?
Yeah, so that's a very good question. Quite hard to answer. That on that project, cost was considered, and I think that was part of the reason that the track lower was also the preferred option, as well as the disruption that raising the bridges would have caused to the roads nearby. What we try to do is provide the carbon information that feeds into this decision making, or sort of multi-criteria options analysis and that sort of thing, where you've got carbon alongside cost and quality and construction program and all of these different factors and social value and other environmental considerations. And it's really then up to the client or us working in the industry to work with the client to determine how do you weight those different factors, and those factors need to then be brought together to make that overall decision making. So, very aware that carbon isn't the be all and end all. It's extremely important, but there are various other factors. But it's about providing the right information to feed into that wider decision making. And what can be really effective, and something I'm trying to work with my clients at the moment on doing, is establishing a cost of carbon. So there are costs of carbon out there in the industry, but they're kind of not perfectly defined yet. But there are different numbers out there, and clients can establish their own cost of carbon. So what they think of as the value of a carbon emission, or sort of the cost to them of carbon emissions. If you can do that, you can convert your total carbon into a shadow carbon cost, or just a cost number that can be integrated into your cost assessment, and that can be quite effective as well. But yeah, it's difficult. Quite often cost wins the decision, but it's our job to try and influence that, and particularly the whole life consideration, to say, it can be often decisions are based on capital carbon and capital cost. So how much does this cost now? And this is cheaper, and it's got, oh great, it's got lower carbon now as well. Let's make that decision. That's where we're trying to drive that whole life carbon and whole life cost thinking and consideration, to say, yes, it's lower carbon now, but have you thought about the replacements that will be required, the repair and maintenance, and then when it reaches its end of life, look how bad it is for the environment and how all of these horrible waste management processes. So, yeah, sorry, hope that answers the question as well.
It's not easy, sure, it's not easy. It's just about education and awareness and keeping persevering with it. So we've got another question here from Gareth. Gareth, would you like to unmute yourself and ask your question?
Yeah, it was just a quick question on the GRP in the case study one, and maybe if there was any reason why that came out as the worst option.
Yeah, it's a good question. So the GRP that was assessed in that project was like virgin material, so which the GRP had very high carbon intensity per unit, so per kilogram of GRP versus kilogram of concrete or brick or something, was extremely high. On other projects I've worked on, we've used sort of recycled plastic within those products, and sort of very we've approached the supply chain and found a supplier that provides a sort of sustainable product which is use recycled plastic, and those can have really low carbon impacts. So it was more to do the embodied carbon within that specific material on that specific project, which led that to be very high. And that's what I would say as well is, see these results and things. It's quite important to consider this on each of your projects with the particular supply chain to understand what products are out there, because just because say that GRP was high doesn't mean that on another project GRP won't be the lower carbon option and the right thing to go with.
Thanks for that.
No problem.
So we haven't got any more questions, Nick, so I'm just going to really thank you very much for that excellent presentation. It's such a complicated subject, there's no doubt about it, and it'll be interesting to see where we are in 10 years time and how it's all progressing on, and where does carbon sit in the hierarchy of things like cost and time, etc., as you have explained through the presentation.
Yeah, for sure.
So thank you very much for putting all that together and presenting today. It's much appreciated from the PWI. And I'd just like to remind people for the next 3 weeks, for the next 3 sessions of these Lunch and Learns, not the next 3 weeks because they're every other week, we do have a set of presentations on earthworks and drainage, climate change adaptation type topics. So they will be of interest as well, I'm sure, to a lot of people in this audience too. So just before we finish off, I'm sure everyone would like to thank Nick in the usual manner, as we've got our little hands that we can all use, and give him a bit of a clap. Thanks a lot, Nick. Thank you. Thanks ever so much.
Final point is that everything that I covered today was basically the same content that was in the article. So if people want to read more about it, the article's available somewhere. And feel free to reach out to me by email as also if you have further questions about specific projects. So brilliant. Thanks very much.
Thank you.